Hello and welcome to this clip having a look at empirical formula, specifically calculating it from masses of elements present. So remembering that the empirical formula is the smallest whole number ratio of elements present in a compound, the general technique we normally use is we divide the percentage by mass by the relative atomic mass of each element. And from that step, you divide by the smallest to get the whole number ratio. If it's not a whole number ratio in step 2, you multiply as appropriate up until it becomes a whole number ratio. And then the whole number ratio will apply to each of the elements. So for example, in a compound containing carbon, hydrogen and oxygen, X, Y and Z will be whole numbers. So I mentioned percentage by mass. That's because in most empirical formula questions, the data they give you to work with is actually percentage by mass. In the question that we're going to look at, that isn't the case, so you've just got to be aware of that and how to convert it or use it in some way. So it tells you the mass present, and that's obviously not percentage by mass. You can easily get the percentage by mass clearly because it tells you that there's 0.5 grams. There's two actual ways you can solve this problem. Either you can convert the masses to moles and treat the empirical formula as a mole ratio of the elements, or you can convert the masses to percentages, knowing that the total mass of the sample is 0.5 grams, and then proceed as normal as per the last slide. So let's use the mole ratio technique first. So you have to convert each mass to moles using mass divided by molar mass. So going to the periodic table, you then can get the molar masses. It's the same as the relative atomic mass. So you convert the masses to mole ratios by dividing mass over molar mass, and you divide by the smallest. So the smallest is obviously going to be 0.0125. So that gives us a ratio that isn't a whole number ratio because of the 1.5. So all you have to do is multiply everything by 2 to get this as the empirical formula. Now I'm going to do the calculation using percentages by mass to take you to the same place. So coming back to where we were, this time round you convert each mass to a percentage of the total. So obviously it gives you it in the question, but if you take those numbers and add them up, that will give you 0.5. So what you do is you take each mass and you divide it by 0.5 and then multiply by 100. So that gives you 5% for hydrogen, 60% for oxygen, and 35% for nitrogen. Just doing a quick check that our percentages add up to 100, which they do. Then you divide each percentage by the relative atomic mass of the element using the general technique we talked about a moment ago. So that gives you a ratio of 5 to 3.75 to 2.5. Now obviously that's not a whole number ratio either. So you have to divide by the smallest to get a whole number ratio, and we end up where we were before. Obviously you have to multiply everything by 2 to get rid of the 1.5, which gives you H4N2O3. So either way it takes you to the right answer. Okay, thanks for listening. Until next time, see you soon.